Yes, class. Now I'm going to start here. Now today we are going to discuss about the deep learning for text and sequences. Previously we have learned about the image classification mostly, even though I have shown some examples related to the text, like reviews of movies. We have made one example in chapter 3, but I did not explain that much over there. Just shown the example and given overview of that topic, because at that time it was just the initial stage, so I was not interested to go into the detail of text and sequence data using the deep learning. Now, from today, and we are starting the new topic. You can say the new data structures using the deep learning. So I'm going to start the recording so that we can have. Now, today we are going to discuss about the deep learning for text and sequences. In this lecture, we will cover the deep learning, how you can use the deep learning for text classification, or you can say you can text sequences, or you can say different applications related to the text, like emotions, like you have sentiment analysis, like you want to predict the topic of the book, or uh, you want to predict the author name. Such kind of things can be done by using deep learning for text. So today we are going to start this one. So this chapter covers uh, now this chapter covers pre-processing, because before sending data to the deep learning model, we need lots of pre-processing. For images, there may be a very little pre-processing for the image normalization, or you can say the image augmentation. Such kind of things we have done before sending images to the convolution neural networks. But when we are talking about the text data, because text data is not directly understandable to the deep learning models, so we need a little bit more pre-processing steps to make them, to enable the data to be fed into the neural networks. So first we learn the pre-processing text data into useful representations. We want to represent the data in the form of tensors. So that's why we are afterwards we are able to feed the tensors to the neural networks. You know about the tensors, and these little bit I have already explained about what is a tensor, because your neural networks supports the data kind of tensors, but the text is not in the form of tensor. So we need some pre-processing steps to convert our text into tensor so that we can feed into the input layer of neural networks. Then working with the recurrent neural network, it will be inshallah covered in the next class. And then using one D convolutions for sequence processing. So these are the three major contents of this chapter we will cover related to the text data. Now, this chapter, again, little bit details. This chapter explores deep learning models that can process text data, time series data, and sequence data. Now, text data, you can say understood a sequence of words or sequence of characters. We will learn these both aspects of text. Then time series data, which changes with the passage of time, and then sequence data. We will learn this in next class. The two fundamental deep learning algorithms for sequence processing are recurrent neural networks and 1D convent. I already gave an example in previous classes, RNN. The RNN always used when you data when the events are occurring one after the other. So that's why we use in such kind of situation we use RNNs, and then 1D converts also. Then one dimension version of 2D converts that we covered in the previous. Now I have already given you an example of ConvNet in previous chapters. So we are now going for the depth of the text data. Now, applications of these algorithms related to the text and series data, document classification and time series classification. You can perform these two tasks, more popular tasks like such as identifying the topics of an article or identify the title of a topic of a book or any article or any kind of document. You want to identify which topic should be the title of this article, and then also you can predict the author of the book. Now then, time series comparisons such as estimating how closely related two documents or two stock prices are. So you can have such kind of time series comparisons. Then sequence to sequence learning, such as decoding an English sentence into French. It's just conversion from one language to another one. So this is named as sequence to sequence learning. Then sentiment analysis, like reviews of the movies, can be positive or can be negative, or the message that is sent exchange between two users or two persons on any tweets or anything. You can find out this tweet is related to is a positive sense or in a negative sense, or you can find out the topic of the discussions made on any messaging uh, what you call it, like WhatsApp or any Twitter. You can find out the topic of discussion, or you can find out sentiment analysis is also related to such kind of text. Then time series forecasting, such as predicting the future weather at a certain location given recent weather data. So this is also prediction. So you can make the prediction, you can make the classification. So such kind of task can be done while having a text data. Now, further applications here, examples focus on two narrow tasks. Now, next examples, we work on sentiment analysis, especially, or you can say the text data, where we can find out the for what you can, where you can predict the label for giving a text. Either it is a positive review or is it a negative review. A task we approached earlier in this book. We have already made this one, but we did not discuss in detail how we have come up with this such kind of sentiment analysis. Now, temperature forecasting is also there, and then the more very and also you just keep in mind a note is here. The techniques demonstrated for these two tasks are relevant to all application listed in the last slide. So such kind of whatever we have discussed in this slide, they are correlated, and then can use same type of models for making this prediction or forecasting or semantic analysis. Now we are going to jump into the sequence data so that we can understand about the text, little bit about the text data. Now, text is one of the most widespread form of sequential data. This actually, when we talk, when we write the sentence, a sentence has always some sequence of words. So that's why we call it a sequence of words uh, having some meaning. The words are correlated, can be correlated. Usually in a sentence, words are correlated and they produce some meaning. So it is a sequence of characters as well and a sequence of words. A sentence, you can say, break into two levels. The first level, sequence of characters, and the second level, you can break it as a sequence of words. It's most common to work at word level. We usually create models in our real life or in neural networks using the word level, what you call sequence, not at the character level, but it can be possible. You can go through the character level or you can go to word level. But mostly the popular method is word level because word has some meaning. A character have not a specific meaning. So for sentiment analysis, you need some meanings. The gist of the you want to predict the the label of the text, like positive or negative reviews. So we usually work with words. Sorry. The deep learning sequence processing models can use text to produce a basic form of natural language understanding, sufficient for applications including document classification, sentiment analysis, author identification, and question answering. Sometimes question answering, but there must be a boundary in a constrained context. Means you cannot make your question answers out of the bound. You can have question answer within limited topics. So it can be done also. None of these deep learning models truly understand the text in human sense. Now, this is very important. Your model is not understanding the sentence. They are not able to understand the sentence, but they can predict the labels. They can predict the uh, what do you call, label the articles. They can give you the theme of the, what do you call it, the title of any article or any book. So such kind of things can be done, but the deep learning model does not understand the meanings of the words like human. Now, deep learning
सर
sequence, yes,
एक सवाल था इसमें,
जी जी,
ये जो है आप कह रहे हैं कि सर टेक्स्ट जो है पर्टिकुलर सीक्वेंस डेटा को फॉलो करता है, सीक्वेंस इन वर्ड से सर ग्रामेटिकल कोई स्ट्रक्चर फॉलो करता है, कोई और स्ट्रक्चर फॉलो करता है?
नहीं ग्रामेटिकल तो नहीं, मैंने कहा कि मॉडल्स आपके समझते नहीं है कुछ इसको, ग्रामर को या वर्ड्स को, बट वो सीक्वेंस को समझते हैं कि ये वर्ड इसके बाद होगा, ये इसके बाद होगा, ये हो सकता है। बिकॉज लाइक एरेज है, एरेज में आप देखें तो एक इंडेक्स होती है, तो अब अगर उनको इंडेक्स वाइज सॉर्ट करें एक सेंटेंस को, तो वो उसकी सीक्वेंस मेंटेन कर सकते हैं। इसके एल्गोरिदम्स हैं टू मेंटेन द सीक्वेंस ऑफ वर्ड्स, बिकॉज इन रियल लाइफ वर्ड्स की सीक्वेंस की एक मीनिंग होती है। अगर मैं उनकी सीक्वेंस आउट कर दूं तो मीनिंग उनकी नहीं रहेगी, ऐसा होगा। सो फॉर दैट पर्पस वी मेक द text classification by keeping the sequence in same order as they present in any message or any book. So this is the only way, the purpose we need the sequence. Otherwise, there's no need.
जी सर, वो सीक्वेंस की बात वो समझ में आ रही है, जैसे कि आपने कहा कि पर्टिकुलर अगर सीक्वेंस होते हैं उसको वो फॉलो करता है। अगर मैं सिंपल से बात करूंगा, एक सेंटेंस लिखा हुआ है तो उसकी ग्रामेटिकल पार्ट ऑफ स्पीच में एक सीक्वेंस होती है, अगर उसी को फॉलो करें तो हमें स्ट्रक्चर मिल जाएगा, अगर फॉलो नहीं करते तो स्ट्रक्चर नहीं मिल जाएगा। तो मेरा
मगर वो,
सवाल उसी
जी
तरीके
जी
से
हाँ,
था, जो स्ट्रक्चर है वो स्ट्रक्चर
वो
किस चीज
वो
को फॉलो कर
वर्ड
रहा है?
टू वर्ड, वन आफ्टर द वन, जो सीक्वेंस वर्ड्स की है, नॉट ग्रामेटिकली उसे नहीं समझता। ये मैं आपको क्लियर कर दूं, ना वो ग्रामर समझता है, ना वर्ड्स की मीनिंग समझता है, ये उसके पास नहीं है। बस एक सीक्वेंस है जो है, जैसे एरेज में कोई सीक्वेंस आपकी होती है, मैं वर्ड्स को एरे में रख दूं, तो क्या वो एरेज किसी भी प्रोग्राम वो उसको समझेगा? नहीं समझेगा, उसको बस सीक्वेंस होगी इंडेक्स की वजह से। So in such a way, I will run the example. You will understand that for the details of your question. For time being, you can just say the model does not understand the sequence exactly, sequence and meaning does not understand, but we try to make them to keep the sequence of the word, sequence of the sentence, or you can say the text. We make such kind of algorithms, such kind of techniques to keep the order of the words same as they present in any message or any text. Still clear, class? Can I proceed?
यस सर।
Okay, so further you will learn as soon as I finish the example, because we have example also in previous classes. I have also some text and related example, so it will be easier to understand once I finish the lecture. If still there's any confusion, you can ask at the end. Now, deep learning sequence processing models. These models can map the statistical structures of written language. See, statistical structures, not the grammatical structures, which is sufficient to solve many simple textual tasks. Not all tasks, but major of the so many tasks which are solved by just having a structural structure of any language. So deep learning for natural language processing. Now, deep learning for natural language, NLP is a word used for natural language processing, is a pattern recognition applied to words, sentences, and paragraphs. We are applying some patterns on this one. In much the same way, the computer vision in pattern recognition apply to the pixels. Like we understand on the pixels that this is a face, this is a dog, how we are doing this, even though your CNN does not understand the faces. but it can find out the face within an image. A human face वो आपको find उसके bounding box दे देगा. वो कैसे कर रहा है? Just having some structural, statistical calculation, structural behavior, your CNN model can find out the face in an image. Similarly, we can have words, sentence, and paragraphs by having some structural mechanism to try to understand what is written, what the theme of the text, what is the purpose of it. Is it positivism says, for if I say is a classification, you can say this review is positive or this review is negative. So you can basis on these structural, you can say structural statistical structures, you can find out such kind of classification results. So like all other neural networks, deep learning models don't take as input raw text. For text mining, for text data, for text classification, your deep learning does not take text directly. So they only work with numeric tensors. I already explained, they work with numeric tensors. So whatever the data you have, whenever you are feeding to the neural network, it should be in numeric tensor. So for text data, we are supposed to convert into the numeric tensor. For this purpose, we need transformations. We need pre-processing steps. Now, what is vectorization? We are now proceeding towards the pre-processing steps involved when we are converting a text into a tensor, numeric tensor. Now, vectorizing text is the process of transforming text into the numeric tensor. This is named as a vectorizing step. Now, this can be done in multiple ways. Means you are supposed to vectorize your text. First step, whenever you have any message, the first pre-processing step to vectorize your text, to vectorize your message, the message that you have, the text data should be vectorized. What is vectorized? Now the segmentation text into the words. You are supposed to segment a text, a sentence into words and transform each word into a vector. This is the first method you can do. The second one, segment text into characters. You can segment your text into characters and transform each character into a vector. How? I will show you the example. Right now, I'm just giving a theoretical part. Now, the third one can be extract n-gram words. You can extract more than one words for one index. How? Next, I will show you how we are going to do these three methods for vectorization. Now, the different tokenization and vectorization in detail. Now, the different units into which you can break down text, words, character, or n-grams are called tokens. Whenever you vectorize any text, they create tokens. And breaking text into tokens is called tokenization. So first, you have vectorization. For vectorization, you need tokens. So breaking a sentence into words, and each word has an index number, is named as tokenization. All text vectorization process consists of applying some tokenization scheme and then associate numeric vectors with the generated tokens. These vectors packed into sequence tensors are fed to the deep learning. Now, once you have tokenized, once you have vectorized your words, then you can feed into the deep neural networks. Before that, you cannot send to any deep neural networks. So you can see here the text, your message is the cat sat on the mat. This is your text. It should be tokenized. You can see how it can be tokenized. Each word should have a separate one. Suppose each token contains one word. So you have the cat sat on the mat. So you have, and then full stop. So you have these 4 or 5, what have your 6 tokens from your text. Now the has these dimensions. The has 3 dimensions. Each word has 3 dimensions. So vector encoding to the tokens. Now this is vectorization. This is named as vectorization. Each word has a vector. Each word has one vector. See, each word has one vector with 3 dimensions. Each word has vector. So this is called vectorization of your text. Now this data, this numeric matrix from 0.01 to 0.01 till here, you can feed into any neural networks. So this is the simplest way to perform pre-processing for vectorization using tokens. First you have a text, then tokens, and then vectors. So this data can be feed into the neural networks. So this is a pre-processing, a simplest way to make your text into a numeric tensor. So you can see back here. Now there are multiple ways to associate a vector with a token. To measure, there are many ways. I have shown one method over here. So we have so many methods to make your data into vectorization. For vectorization, you can have so many methods. You can have so many methods for vectorization. So now we have one hard encoding. First method is one hard coding, and the second one is word embedding. The first method we will cover example for both, one hard encoding tokens and then word embeddings. These both methods have different what you call it, different advantages and disadvantages. So I will discuss in next slide. So I just repeat for your summarization. Whenever you have a text data, it should be vectorized to convert into the numeric tensor. For vectorization, you need to make tokens first. First, you make tokens, then vectorize. Once it is vectorized, then feed into the neural networks. Now, for vectorization, you may have many methods, but here I have discussed two popular methods. The first one is one hard code encoding method, and the second one is word embedding methods. These two methods, we will have examples in Python code, and I will show you how they work and what are the advantages and disadvantages for these two. Is it clear, class, for till that point? Is there any query? If you have any query, you can ask right now, class. Are you
हेलो
there?
सर
Yes.
सर ये इसमें जो वेक्टर जो बने थे वो 3 डायमेंशनल क्यों बनाए हमने जैसे दा के
वो आगे बताऊंगा.
ठीक
I will discuss why we need this. Why we need this. This. You are talking about this one, class? This one? So this is one method. I'm not showing all method. This is one of the method. Why we need this? You will get the answer as soon as I will jump into the example. So right now, if there's any confusion in these terms, I'm asking about the things that we have finished till slide 9. If there's any confusion till this point, you can ask. Is it clear the concept of tokenization, vectorization, and then these all things?
सर
Yes.
इनमें से इन्होंने कौन सा मेथड यूज किया जो इन्होंने कन्वर्जन की है वेक्टर इनकोडिंग की है इनमें दो मेथड आपने बताया इनमें से इसने कौन सा
ये
किया हुआ है
वर्ड एम्बेडिंग है, ये वर्ड एम्बेडिंग है. इस वक्त जो दिखा रहा है ये वर्ड एम्बेडिंग है.
सही है सर
Okay, so I will discuss all both of the with example. Right now this is word embedding, but यहाँ पे नाम इसलिए नहीं लिया ताकि आप confuse ना हो. इसको just ये maximum जो आपको दिया गया इस तरह है. Is it clear, class? Can I proceed? Is there any query
नो सर
regarding the application, regarding the words? Because you keep these words in your mind so that I can explain the example. Otherwise, hard to explain the example. It's a little bit different from image classification. Is it clear, class? Can I proceed? If you have
जी
any
सर
confusion, you can ask the queries. You can, okay. Now, Next is little bit few terms. The next term we are going to learn is bag of words. Before starting the example, I need some terms so that you will be able to understand. The next term we are going to learn. Now I will jump into these two examples, one hard coding and word embedding. Before starting to learn these two methods, I need some what you call it, we need to some explain some concepts, two or three concepts more. The first concept is bag of words. Whenever you are talking about the text data, you need bag of words. What is bag of words? I'm going to just explain here. Bag of words, simply we call BOW, is a method of to extract features from the text document. Simply you can say like this: you are supposed to extract the features from the text document, not from the image. So this is something different. You are extracting features from the text document or any text message or any article. You can say any text data. Now these features can be used for training machine learning algorithms. Once you have these features, you can send these features, this data, or you can say the numeric vectors to the machine learning algorithm. It creates a vocabulary of all unique words occurring in the document in the training set. Bag of words is consist of the words of unique words. It consists of unique words. See here, it consists of unique words. This is your text. It consists of unique words which have some meaning and their occurrences. You can say this is your occurrences and tokenization, not vectorization. Tokenization is something different. I repeat, tokenization is extracting the words, putting into the bag of words. So, and that the number of occurrences. You can say how many times a word has been used in this text. So this is the bag of words. So bag of words is nothing. It creates a vocabulary of all the unique words occurring in all the documents in the training set. Okay. In simple terms, it is collection of words to represent a sentence with word count and mostly this regarding the order in which they appear without keeping the order in the bag of words. So disregarding the order of the words. So this is the major disadvantage you can say of the bag of words. Bag of word does not keep the order of the words, but it keeps all the unique words, not the repetitive words. For example, here a word I can see is love. Love will be represented once, but it counts can be 5, 6, 3. But the word love cannot be repeated 2 or 3 times in bag of words. It should be once with number of counts. So Bega word is an approach widely used with natural NLP. I already explained. Information retrieval from the document. What information can be retrieved from the document? To find out which topic, on which topic this book has been written. So you can find out the topic of the book without reading the book. So this is named as information retrieval. And then document classification, I already explained. You can classify the document, that this document is relevant to which category. Maybe a novel is written on what a fiction novel hai ya koi aur hai. You can find out the classification as well based on the documents. So this is all about the Bega words. Any inquiry class for Bega words? Okay, I assume that you will understand. You are understanding the point of view. Now the next one is n-grams. I already used this word n-grams. See here, I have used this word here, n-grams. Now I'm little bit giving you the words n-grams. What do you mean by n-grams? So n-grams, you can see here. Now, what is the n-gram? Word n-gram are, before this, I want to show you this picture. If I say this, I have a sentence, this is book data, big data AI book. Suppose this is your sentence. So make if I make tokens, so in such a way that each word is separately indexed, you can say. Each word has separate representation, separate index, then it's named as unigram. Or the second using the bigram, how the words are selected, this is big, big data, data I, means two words represent one index number. So this named as bigram. And similarly, you can have three words to represent one index. So such kind of tokenization is named as n-grams tokenization. Is it clear, class? Okay. Now, word n-grams, let me just explain this one. Word n-grams are groups of fewer consecutive words that can be extracted from a sentence. The same concept may also be applied to characters instead of words. So you can apply same concept for the characters as well, not for the words only. So here, simple example, we have two examples here. I have already shown the example. Now, last sentence, I just make very important for you. Such a set of called bag of 2 grams. Now, I already explained bag of words. Now, if you have two words, so you can say bag of 2 grams or bag of 3 grams. Instead of words, you can say it such a way. So this is what you can say is a tokenization method. The term bag here refers to the fact that you are dealing with a set of tokens. So this is a tokenization actually, rather than the list of sequence. The tokens have no specific order. You keep in your mind, tokens not have a specific order. This family of tokenization method is called bag of words. So such kind of tokenization can be named as bag of words for 3 grams, for 2 grams. So this is a brief explanation of bag of words and the tokenization using the n-gram method. Is it clear, class? Any query, any question? If you have any query, you can ask right now.
Yes, sir.
I'm trying my level best to explain it with a
Sir.
with better explanation. If there is still any confusion, you can ask.
सर
Yes.
सर ये n ग्राम का अगर साइज उतना ही हो जितने मतलब सेंटेंस में वर्ड हैं
तो फिर
तो
मीनिंग किल हो जाएगी ना। देखें आपने अगर इस तरह तो फिर मीनिंग नहीं बचेगी। ये आपको आगे एग्जांपल जब आप रन करेंगे तो आपको आइडिया होगा कि हाउ इट इज यूजफुल। यूजुअली वी यूज यूनिग्राम, यूजुअली we do not go for even bigram trigram, but it can have application, हो सकती है इस तरह भी। So जितने वर्ड्स आप मिलाएंगे उतना उनकी वेक्टराइजेशन में उसकी मीनिंग किल हो जाएगी। यानी उनकी अगर मैं एक जुमले को एक इंडेक्स दे दूं तो वो उसके लिए एक नंबर होगा, वो एक नंबर से उसे पता ही नहीं चलेगा कि उसकी मीनिंग क्या है। सो व्हेन ईच वर्ड हैज डिफरेंट मीनिंग देन वो कुछ अंडरस्टैंड कर। जैसे मैं अगर ये कहूँ कि बिग एंड लार्ज मैं कहूँ ये दोनों सेम है, मैं दोनों को मिला दूं बिग एंड लार्ज तो कैसा लगेगा? यू कैन अंडरस्टैंड। सो हाउ यू कैन से बिग एंड लार्ज आर सिमिलर व्हेन यू हैव इंडिविजुअली अलग अलग हों फिर मैं उनके जो वेट सेम रखूं तो फिर मुझे आइडिया होगा हाँ ये नियर बाय है, ये तकरीबन एक जैसे हैं। So this is the way we apply mechanism apply to understand the words statistically, or you can say by having some numeric values. Numeric vector होगा तो पता चलेगा, वरना पता नहीं चलेगा. Later on I will show you the example so that you can understand why we use this one. But there are possibilities. You can use unigram, bigram, and trigram. Any other question, class?
सर ये जो n ग्राम है, जैसे हम किसी पर्टिकुलर सेट के सबसेट बनाते हैं, ये इसी प्रोसेस को थोड़ा बहुत फॉलो नहीं कर रहा?
जी जी बिल्कुल ऐसा ही है, बिल्कुल ऐसा ही है। बट इसकी देखें आप कुछ वो है, आप कुछ उस तरह एग्जैक्टली वो सेट्स नहीं है, एग्जैक्टली नहीं है, इसकी डिस्ट्रीब्यूशन डिफरेंट है।
लिमिटेशन दे रहा है ना, जैसे बायग्राम है या ट्राइग्राम, हम उसी सेट्स को ले सकते हैं।
हाँ जाहिर है, आपने देखें, आप देखें टेंसोर जो है उसकी एक साइज फिक्स होगी ना, आप अपनी तरफ से नहीं कर सकते ना। टेंसोर की आप 2 रखी तो सारे वर्ड्स 2 होंगे, वरना फिर वो आपकी वो बनेगी, उसकी जो आपका एल्गोरिदम है वो इतना फ्रूटफुल नहीं होगा। इट्स मैंडेटरी टू कीप द 2 words, 3 words or single word. Usually we use unigram, usually instead of character or bigram or trigram. मैंने कहा ना कैरेक्टर वाइज भी हो सकती है, मैं पहले कहा था आपको कि कैरेक्टर वाइज भी टोकनाइजेशन हो सकती है। मगर वो इतनी वो फ्रूटफुल नहीं है इन सेंस ऑफ व्हाट, इन सेंस ऑफ अंडरस्टैंडिंग. ह्यूमन के हिसाब से जो है ना, वो कंप्यूटर से समझता नहीं, आपकी मशीन लर्निंग उसे समझती नहीं. बट वी पीपल अज्यूम वर्ड्स हैव सम मीनिंग. Okay, so usually it's better to have unigrams for models. Usually it's a popular method. The algorithms use unigram methods for tokenization so that they can relate the word with each other. They can say these are the common words, have same meaning. If the two words are placed in one token, then it assumes that it's a one word, or it assumes there's nothing, just one thing. Usually we do not prefer such things. So I hope you understand a little bit, but when we have example, it will be more clear.
Okay, sir.
Okay. Any other one have query? Can I proceed, class?
सर
Yes.
जब हम इनकी डिस्ट्रीब्यूशन करें जैसे यूनिग्राम और बायोग्राम में, अगर ये जो हमारे जो सेंटेंस है उसमें सारे के सारे वर्ड यूनिक हैं, अगर किसी रेपिटेशन हो तो उसके हिसाब से भी यूनिग्राम या बायोग्राम में उसकी रिपीटेशन होगी.
डेफिनेटली वो अगर आप बायोग्राम में रखेंगे तो वो रेपिटेशन होगी, वो उसको
अगर
सीधा ही करेगा.
यूनिग्राम में
उसके
रख
लिए
रहे हैं
उसी लिए टेक्स्ट नहीं है. देखें आप जरा सा और से अगर देखें तो ये इसको न्यूमेरिकली डील कर रहा है, ये इसको टेक्स्ट डील नहीं कर रहा. क्या ऐसा आपको नहीं लग रहा?
जी सर.
उसको ऐसा लग रहा है जैसे ABC रखे हुए हों, AB साथ रखें, BC साथ रखें. डजंट मीन फॉर द न्यूरल नेटवर्क्स. उसके लिए वर्ड्स की कोई मीनिंग नहीं है. मैं अभी तक यही कह रहा हूँ कि वो डीप लर्निंग के जो मॉडल्स हैं, दे वर्क्स ऑन टेंसर एंड न्यूमेरिक्स. दैट डज नॉट अंडरस्टैंड द मीनिंग ऑफ द वर्ड्स. वो एक दो साथ हैं या अलग हैं. ये हम उनसे काम मीन्स यू समझे कि हमने बेटर रिजल्ट्स लेने के लिए टेक्निक अप्लाई करते हैं. Maybe sometimes you need 2 words per index. Sometimes it's possible. ये हो सकता है ऐसा, कहीं पे ऐसी application हो. But right now I have one application here for unigrams, so that it will be easier to understand. But there are methods in research for biogram and trigrams. Any other query, class?
No sir.
Okay, can I proceed? Okay. Now the next step is jump into the one hot coding. I have discussed this one, class. Where I have discussed, I'm back here. Multiple methods for tokenization, for vectorization, because you need you need tokens for vectorization. Am I right? You need tokens for vectorization. So you have two methods: one hard coding tokens, and then word embedding methods for tokenization. So these are the two methods, usually popular methods for text data. Now I'm going to explain the first one. What is a one hot encoding tokenization method? Now here. Now it is most common, most basic way to turn a token into a vector. Note you saw in action. Now I have already given example in the previous chapter, but did not explain each and every line, because to just show you that we can use deep learning model for the text. And afterwards, I have focused on images only. If you remember, if you recall your memory, that previous lectures, I have focused on images apart from the text, even though I have shown one example. So right now I'm recalling that one, same example, and with some details so that you learn the details of the text classification. The example previously we have discussed is about the reviews of the movie. A review can be positive, a review can be negative. So in previous example, I have just given the code and shown you the output of the model. Now, right now, we are going to in some details. Now here, it consists of association of a unique integer. What is one hot coding? I mean, just little bit explanation. This method is associating what? Unique integer index with every word. Each word has some index, and then turning this integer index I into a binary vector of size n, the size of vocabulary or size of dictionary. You can say is a size of vocabulary. Sometimes we call it dictionary. The vector is all zeros except for the ith entry, which is 1. Just you can see this example, class. Now see, this sentence contains how many words? 1, 2, 3, 4, 5, 6. So you can see we have 6 position, 1, 2, 3, 4, 5, 6, 7, because there is also full stop, or you are not using the zero index. Sometimes you don't want to use the zero index. So we usually keep the vector size 1 plus compared to the words in a sentence. Suppose here I have how many sentence words? 1, 2, 3, 4, 5, 6. So the array size will be 8, because we are usually do not use the zero. Usually avoid the zero, keeping the zero index out of use. But you can use it. It's not the case that you cannot use it, because we want to start the loop from 1 till onwards. That's why we do not start the loops from 0. This is the only reason that I can understand. Whenever you want to read an array starts from 0, while you want to start your loops from 1 and onwards. So usually the algorithms, they omit the first index for the use while using tokenization. This is the only reason that there's nothing in the 0 position. So can you see here, class? Now the has first position, cat has second position. See, all are zeros except the index 1, index 2, index 3, index 4, 5, and 6. So if I write the index of this, the what you call it, the vectorization of or of this one is, you can see the first one is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So this is the index number for this sentence. So this is the such kind of, you can say, transformation is named as one hard encoding. Means each word has only one binary number in throughout vector. In throughout vector, only one position has 1, rest of the indexes will be 0. So such kind of conversion named as one hard coding for words or characters can be, also characters can be possible. See another example, you can see one hard coding words. Can see here, class, the problem with big of words. Now see, and when you have a big of words, there will be no order. If there's no order, it means there will be no semantic information. You lose the semantic information once you uh, uh, lose the order of the words, while the order of the word matters a lot. In so many cases, if you change the order of the words, the meaning will change. So disadvantages of one hot encoding big of words can be no semantic information. Then sparse data. Sparse data means your data will have so many zeros and only one has in one position has only one. Mostly they have zeros. So this is named as sparse data. Now high dimension representation. Suppose you have, suppose if I say you have a large words, so you can have very high dimensions. Suppose you have 5 sentences, 10 sentences, 100 sentences. Then you need to have a large dimension to create. Here I'm just giving you one sentence example. But if you have more than one sentences, usually we have, then you have a large number of dimensions, which is a sparse data. And without any order, there will be no order. So such kind of representation for characters and words have some disadvantages. Now we are jumping into the example now here. Now, first of all, we are going to create the bag of words. Let me show you the example first so that you can understand. Can you see this without Keras? We are tokenizing without using the Keras library. You have easy way to use the Keras library. Here, I just shown you to give you the core concept, how Keras library works. So that's why, first of all, I'll show you the example, which splits, which tokenize your data without using any Keras library. So here you can see in this example, you have NumPy, and then you have 2 sentences here. The first sentence is the cat sat on the mat, full stop. The second sentence is the dog ate my homework, full stop. So you have 2 sentences in the data, in the text data. Now for this one is an array for tokenization index. Now in this loop, you can see why each word has been splitted or created one vector using using what? Using this one. See the first word, this is the first sentence matrix. This is second word matrix. The first sentence, you can see first we have tokenized this one, split the sentence. You have split the sentence like this one. The cat sat on the mat. So split the sentence. You can have first you have split the sentence, and then second, these are the words you have over there. I'll show you the code over there so that you can see this code, how this works. And then second sentence, similarly, you have tokenization, and then they are converted into these binary matrix as I have a matrix as I have shown here. Similarly, I have converted by using a code in Python to convert your text into vectors. So these two sentences are converted into two vectors in such a way. So first of all, what we see in which sentence have maximum words. So find the maximum words if to keep the length of the array with maximum number of positions. So, and then you have count the words. So for example, here you have one index is more than, because zero, we are not using zero. So we have one more index, and then all these words. For each words, you have a number of rows. So each row represent one word. Each row represent one word. You can see here. Now you can see, come here, class. For the next one, you have index for zero, you have the, so that you have one here. And then you have next sentence, dog. You can see dog is here. And then you have 8, you can see here, my is here, and then homework is here. Rest are blank. See, rest are blank. There's nothing placed in rest of the words because there's no new word over here. We have no new word. We have extracted the new unique words in both of the metrics. First matrix have all the ones you can see here till here, because we taken the larger matrix. The matrix size is more than maximum 10. So you have 10 size of each matrix, because we did not count the words, but you can keep it according to the length of the sentence. So let me show the example so that we can proceed with the example. Then we will be, now this is the example you can see here. I can show you the example here, class. Now first of all, this is the example that I have. I will I will execute this example by copying this one first from here to anyone, and then clear this screen, clear this graphs, so that you will be able to understand. So this is word level tokenization. If I run this, you can see here. Now you can see here, I will
सर
show you variables. Yes.
हाँ सर, अगर कोड थोड़ा सा जूम इन कर दें तो अच्छा हो जाएगा, नजर थोड़ा कम आ रहा है।
हाँ, वो तो वहाँ स्लाइड से होगा बच्चे, स्लाइड में मैंने रखा हुआ है। अगर यहाँ पे ये थोड़ा सा विजिबल है, इट्स इजियर टू अंडरस्टैंड। कुछ यहाँ पे कुछ है, कुछ विजिबिलिटी है बच्चे,
जी सर, ठीक है।
कुछ बेहतर है।
जी जी सर।
हाँ, अब अगर फर्स्ट सेंटेंस numpy, because I'm using the numpy, and then this is the input data, 2 sentences, first sentence, second sentence. I have taken just 2 sentences here, and then this is an array declaration for tokenization. Okay, class builds an array to tokenize data, and then read the sample. Sample means, in sample it means you are reading one sentence at a time. First sentence and then second sentence. So this is a for loop for sentence. First time it reads the overall sentence, second time it reads the next sentence. So I assume that first time it is reading this one, the cat sat on the mat. It is in samples. Now we are taking, splitting the each sentence in the words. So here in word, first time I have the from the first sentence. So the word, if word is tokenized in index, not in index, if it is not already there, then you are supposed to index here. So you can have index in one position +1, because I don't want to use the first index. So start from 1, already explained. So similarly, when this loops continues, it will read all the words from first sentence first, and then takes the second sentence and similarly creates the two matrix. And here, this is just a display of the length results. So here, what we have done is we have just displayed the vectorizing the sample. Now here, you are just vectorizing this one. The first one is the tokenization. This one is tokenization, means you have created the words like this. Can I show you here? The first loop is making this split, this tokenization. The second one makes this conversion big of words. The first one is tokenization. So first loop is making to break your words, sentences into words. Once it is broken, so you have words in here in this one. This is the tokenizing index. This variable contains the words, these words, and this one is used in this one for creating the matrix like this one. So this is a manual method. You're not supposed to use for your example, but if you want to use, you can use it. We use Keras library, which will directly convert into these matrix. So for your understanding, this is shown here so that you can convert manually. You can convert manually without using the library. So back to the example here, class. So I have just executed the same example. The first one is what you call it, samples. What are the samples? You can see sample right now. I have only the next sentence. However, the samples have two sentences. Samples have two sentences. In first time, it reads the first sentence. Second time, it reads the second sentence. And then we have token index. You can see here, Clark. Each word has an index number. See, it is given here. I just make it the order. The is first, Kate is second. Similarly, each word has an index number. And according to these index, these arrays has been created. So this is the way you can create your, you can perform the hard-coded encoding vectorization or tokenization. So you can use this method. This is a manual one. Is it clear, class? Is there any confusion? I think it's very much clear. There should be no confusion. So this is a manual example that I have shown to you. So next example is about the characters. Same example, but character wise. Right now, the example is word wise breaking, word wise tokenization. The next one can be of character wise tokenization. So same example, your words are tokenized by using the characters one by one. So same example, I have already uploaded this one into your what you call it in your LMS. I'm showing you again here. You can see, class, this is same sentence, same samples data. We are going to split each character and then make them indexed. This is a simple one. You can say the maximum length of each word is 50. So you can have this code. You can apply this code to create the data like here. I can show you. You can see here. Now each character, this is your dictionary, which is already there. This is each word has its index. So how many words, the total words we have. And then suppose if I say A has index number 11, you can see in the first sentence, A is 3 times, 1, 2, and 3 times. So 11, A is 3 times, 1, 1, 1. See, rest are zeros. At 11th position, you have 3 ones. Similarly, 13, what is 13? 13 is C. So C is 1 time. You can say C is 1 time here. So you have 1 here. 15, what is 15? 15 is nothing, just E. E is 2 times 1 and the 2 times. So this is 15 is 2 times 1 is here. So this is a kind of a sparse matrix using the one hot encoding at the character level without using Keras. Here you can see we are not using Keras. This is the example that will manually convert your sentences character wise into the hard encoded what you call it vectorization. So this is the two ways you can create the bag of words. Once you created the bag of words tokenization, then you can feed this data. This one you can feed into, this one can be fed into. Now this one can be fed into the neural networks for classification, whatever you have. So this is looks like you can say numeric data, numeric tensor, which your first input layer will accept this data. So this is a pre-processing for your text before making any task like classification or sentiment analysis, or you can say author identification or topic identification, or we can find out and label the article. Such kind of things you can make once you pre-process the data. You make your data vectorize, tokenize, and then vectorize. Then you will be able to make some classification or predictions or whatever you want. So these are the two simplest method. I hope it will be easier to understand, and then you can understand these two methods. Is there any query, class? You can run this example at home. You have a book, go through the book, go through the slides, go through the code. You will be able to understand more in more detail. Right now, you just take the concepts, how it works. Any query, class? Now, this example is with Keras, same character level, but with Keras. This example is, sorry, this example is word level with Keras. You can see this example is word level with Keras. Now we are using Keras. Now this is easier way. You can make it manual. I already explained. Same example is done manually by using this one. See, this is same example using without Keras, word level hard encoding without using Keras. But now I'm showing an example that is, this is the example where we are using Keras for word level one hot coding or one hot encoding. You can see here, this is the library that you are calling for tokenization. You have same samples. Now tokenizer, you can have number of words. You want 1000 words. Assume you have 1000 number of words and you have samples. Number of samples are here. You have given the text as a sample. Now create the, you can say that sequence of words. Words are broken down, and then for each one you are supposed to tokenize, create a one hot results by having just this command. You can have binary because all will be zero except where the position of sample is there. So it's by having this command, you have one hard coded vectorization, and this is your tokenization, this is your vectorization, and simply you can have index over here, so you can see the index. Now I show the output of the data so that you can understand. See, this will be the result of this code. Word samples are this one. Word sequence will be like this 1 2 3 4 5, and these are the index of each word. So you can see the has one index, cat has two index, set has three index. Similarly, you have index for all the words, and you find now 9 indexes. How it will represent data, you can see here, class. I'll show you this one a little bit. Now this is the representation of, see here, this is the representation of encoding. See at position 1, you have two words, the one is here. Second, only cat. Second is only cat, so 1 is here. So 2 sentences, 2 rows. These are the features, you can say. These are the features, and you can say in such a way. These are the words, instances, 0, 1, 2 instances, 2 sentences, while these are the features. Similarly, as you can feed in the neural networks. So this is the way you can use directly by having Keras to convert your data into the one hot encoding vectors, vectorization. This whole process is related to the vectorization of the data. So vectorization is important because you cannot send directly text to the neural networks. So before sending your text to the neural network, you are supposed to tokenize first. Once it is tokenized, it has index number, then you can convert into the vectors. So each word is converted in some vector. So vectorization is required before feeding your data into the neural networks. So this is direct method using the Keras. This is your hashing trick. Now it's also possible you can use a hashing trick. When you have a large amount of data, we usually prefer to have a hashing technique. We usually have hashing technique to go for when we have a large amount of data. Let me show the hashing technique. Now hashing technique as way to have a simplest method for data to use this hashing technique. Hashing technique usually works when we have a large number of words. So the hashing technique has some problem, that is, once it can generate collisions. So if two words are placed in one address, so there may be a loss of data, and it is possible. So for hashing, but it's very minimum. If you are using a good hashing function, there will be less collision. So you can use hashing technique to create the vectors for each word using Keras. So this is example for using hashing technique. So you can use it if you have a large number of data, large number of sentences, a book or any large number of sentences. You can use this method for word level one hard coding method. So this is also possible class. I think it's easier to, and I have an example here also. You can have example here also. This one is your hard coding with using your data for this one. So these all 4 examples are here. I have already uploaded in your LMS so that you can see and go through these examples. I've just given the explanation here. Is there any query, class? So the next one is class. Here you can see now the next one is using word embedding. Now word embedding is okay. Give you before jumping to this example, I will give you some time to download this code from LMS and run it and see the results, and then we will discuss, and then I will proceed the next example. Otherwise you will not be able to understand. So go through this example. This is already on LMS. I'll show you. It's already on LMS. If I show you on LMS, just download from the LMS, and then you will be able to. It's already there. Data science. You can see here. It is already there. The PPT, and you can see the code is here. This is word embedding character. So download this one. You will be able to, and then run it and see the results, and then we will discuss. I will give you 10 minutes. Right now, I'm stopping the recording and give you the 10 to 15 minutes or more than this. Just run the example, see this one, and then we will discuss. It will be better. I think so. Is it okay, class?
Yes.
Okay. Okay. I'll give you some time. I will just stop the recording and then switch off the mic so that we can pause the recording and then switch off the mic. So I will be back at 1 o'clock. Okay, now it's 39. So I will be back at 1 o'clock. Just run the code. I will ask each and everyone one after the other.